Hello guys, now we are going to see the concept of 14 Bravais lattice. Before we are going to the concept, first we have to see the basics. Okay, in Earth, all matter is made up of atoms, and this the combination of atoms we are calling it as molecules, right? And the combination of molecules or the combinations of things are arranged in a such a way. Sometimes it is arranged in a in a correct order. Sometimes the particles are not arranged in like correct order. Okay, and the repeating units, it we calling it as a unit cell, and the repeating unit cell we calling it as a crystal lattice. This is the concept. First, let's see the unit cell definition again. The basic repeating unit we calling it as a unit cell. And in unit cell, the opposite faces are parallel. The edge of the unit cell connect equivalent points. Now we discussed about what is the unit cell and crystal system. What is crystal system? In crystal system, the arrangement of all particles sometimes it not may be same. Due to this, the unit cell shape will get differ. Sometimes particles not arranged in a same position. Due to this, the unit cell shape or edges lengths will get differ. Okay, now let's see the introduction. Like why this Bravais lattice are using, we see now. For if we having one crystal, we want to find out the information of the crystal, how we will get, like that we are seeing now. Now who introduced this concept? The concept introduced by the French physicist Auguste Bravais in 1850. He introduced this concept, and there are 14 Bravais lattices, and majorly it has divided into 7 crystal systems classified. And these 7 crystal systems classified based on their parameters. Parameters means age, length, width, like that, A, B, C, alpha, beta, gamma, and their angles. Okay, what are the 7 crystal systems here? Cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, and monoclinic and triclinic. These are the 7 crystal systems. In 7 crystal system, the cubic is the highly symmetric element or highly symmetric system. What is the least system? Triclinic is the least symmetric system. These are the moderated symmetric systems. Okay, first we have to know what is primitive unit cell and non-primitive unit cell. Primitive unit cell, it contains only lattice points per unit cell, one lattice point per unit cell. But in non-primitive unit cell, it contains additional lattice points. Additional lattice points in the sense, in a simple cube, no additional lattice points is there. But in a body center, if it is a body center, here one additional lattice points are adding, right? This is called as non-primitive. If it is like this, means it is a primitive unit cell, no additional points are here. So this is non-primitive unit cell, this is primitive unit cell. This is the examples, and we will go into the main concept like detail. First, simple cubic unit cell. In simple cubic unit cell, the structure is like this only. All 3 edges and lengths are equal. A, B, C are all equal, and the angle is also 90 degree. All 3 angles are 90 degree. This is the simple cubic unit cell. And rhombohedral. Now we are going to the rhombohedral. Here also all 3 edge lengths are the equal but slightly inclined. So alpha, beta are both are in 90 degree, but gamma is doesn't equal to 90 degree. And this rhombohedral we can call it as also tetragonal. Now we are going to see the, sorry, it is a trigonal. Now we are going to see the tetragonal. In tetragonal, the edge length A, B are equal, but C doesn't equal because it is like more, doesn't equal. And alpha, beta, gamma, three sides are 90 degree only. This is a tetragonal. Now we are going to see the orthorhombic. Orthorhombic, the three edge lengths doesn't equal to each others. A, B, C doesn't equal. And alpha, beta, gamma, all three angles are in 90 degree only. This is the orthorhombic. And monoclinic, three edge lengths are not equal here also. And in monoclinic, alpha and gamma are in 90 degree, but beta doesn't equal to the 90 degree. In triclinic, the three edges are not equal and the three angles also not equal. Example like alpha is 70, beta is 80 and gamma is 90 or 120. This isn't equal to each other. And in hexagonal, the edge line A, B are equal but C does not equal. In alpha, beta are 90. Alpha, beta are 90 but gamma is 120. Now we are going like 14 Bravais lattices. In cubic there are three types. One is primitive, body center and face center. In primitive is simple, same as like that only, primitive. And body center is one atom adding additionally in the body center, and face center is each and every face we are adding one atom each and every face. This is the cubic. And example, the example of cubic system is sodium chloride, zinc blende and copper. Trigonal, in trigonal there are two types, remember this. In cubic there are three types. In tetragonal there are two types, primitive and body center. In primitive it's same only, a simple thing. Like first what we are seeing here, tetragonal, you have to draw, this is a primitive, first you have to draw this here. After that the second type is body center, tetragonal body center. We are adding additional atom in the center of the body. And the example is white tin and tin oxide and titanium oxide and calcium sulfide. These are the examples of the tetragonal. And hexagonal, in hexagonal this is only one type, that is a primitive. And these the diagram is this, the diagram. And example is graphite and zinc oxide and cadmium sulfide. Graphite is nothing, it is a pencil lead. And we are going to see the orthorhombic. In orthorhombic there are four types: primitive, body center, face center and base is face center. What is the thing base is face center? Okay, let's see. This is a primitive and primitive type, and body center one atom adding in the center of the body, and face center each face we are adding additional atom in each face, and base is face center. The opposite face of the cube we are adding one atom additionally. This is called as base is face center. And the example is rhombic structure and potassium nitrate and barium sulfide. These are the examples of the orthorhombic. Now we are going to see about the monoclinic. There are two types in monoclinic. One is primitive, another one is base is face center. The primitive one is same as like that, simple. And base is face center. In opposite side both the face we are adding one atom. In monoclinic the example is monoclinic sulfur and sodium sulfide crystals. Now we are going to see about the trigonal. In trigonal, we can call it as a rhombohedral also. There are one type only, primitive only, and the example is calcite and cinnabar. Why we are using cinnabar? For extracting the mercury. And now we are going to see about the triclinic. In triclinic, there is a one type, that is a primitive. The primitive is the same structure. We are using these crystals and boric acid also. In next video, we will see how we will remember these 14 lattices easily. What is the trick? Okay. Thank you guys.